Welcome to the first of many videos. We're going to be breaking down the new AAMC full-length exam. I'm not sure what we're going to call it. Is it FLE 5 or is it like AAMC free practice test? I'm not really sure. Let me know what you want us to call it. But today we're tackling the chemistry and physics passage number 1. And I got a lot of comments whenever I released that this exam was coming out, that people were saying that they hoped that this new test mimicked how difficult the actual exam was, because they felt like the AAMCs 1 through 4 were a lot easier than the real exam. And let me just tell you something. I've only worked one passage, but so far, you're getting what you asked for. Let's take a look at it. Like always, I'm going to go through this passage, flowchart it out, go through each answer and question, and show you how to get to the correct answer every single time. At IFD, flowcharting is the way that we go through the science passages, not necessarily the cars passages, and condense them down to something a little bit more palatable. If you don't know what I'm talking about, then make sure to check out our video on the flowchart method. So let's jump into this passage. First things first, we read the title, which usually doesn't tell us too much in sciences, as it does not in this one. It just says that it's biochemistry. Okay, tells us nothing. So starting off, it says, HIV-1 protease inhibitors have been successful at lowering HIV-1 levels and blocking the onset of AIDS. Okay, so that seems like a pretty strong relationship. So the more we get these protease inhibitors, which I'm just going to abbreviate as P sub I, then that leads to decreased HIV/AIDS. Pretty important stuff. However, because HIV-1 mutants are developing resistance to current protease inhibitors, new inhibitors like compound 1 are being tested. So there's two things from that last little sentence. The first one is that compound 1, which I'm just going to say CMP1, is one of these protease inhibitors. So it's also functioning to decrease the incidence of AIDS and HIV. But another thing that's very MCAT specific is, do you notice how they mentioned molar mass? Usually that's because you're going to have to use it. So anytime that you see them mention like the molar mass or give some kind of specific mathematical value in a passage, go ahead and highlight that or make a note of it, just to pay extra attention to it, because they're likely going to ask you to utilize it later, and especially if they're going to go ahead and show you the chemical makeup of this. So the fact that they're showing me the chemical makeup, they're giving me the molar mass, I'm going to have to know a lot about compound 1, maybe do some math here, maybe have some questions about polarity with this figure. That's usually why they show you a figure, is to ask you a question about like resonance or polarity or some kind of those chemistry stuffs. So going through it, it says compound 1 has been shown to inhibit HIV protease with a K sub I equal to 60.3 micromolars, table 1. All right, again, that's kind of like specific units. I'm interested in it. They tell us table 1. And then they go ahead and tell us what K sub I is. It's the dissociation constant. Now remember, a dissociation constant is the constant that describes the kinetic parameters of an object or molecule splitting into two smaller parts, or dissociating. It says that this dissociation constant is for the enzyme-bound inhibitor, which is either E sub I or ESI. So EI, I'm going to assume, is the enzyme inhibitor complex, and ESI is going to be the enzyme substrate complex, depending on the type of inhibitor, which that makes sense. You know, some inhibitors bind the EI and some bind the ESI. It's actually really important that you know which of those is which. So I'm going to go ahead and highlight that as well, because they could end up asking us to split the hair between whether this is maybe a competitive, non-competitive, uncompetitive, or mixed inhibitor. So I think that's important. That's a question that they could easily ask you based off of the EI and ESI parameters. It goes on to say that the peptide substrate, peptide, right? Peptides, that's a basic science. We highlight basic sciences, or we make a list of them. The peptide substrate for HIV protease is erkiflic. I think that is an amino acid sequence. So I always like it when they give me amino acid sequences, because it's really easy for them to ask a question of like, what's the total charge of this? And you just go through and you would say, you know, I is isoleucine, so that's 0. R is arginine, so that's +1. K is lysine, so that's +1. And do that for the whole molecule. Those are really common. That's the biggest eraser in the world. Those are really common and really easy MCAT questions for them to ask. But if you don't know how to do it, then you're not going to get it right. So it goes on to say that these proteases hydrolyze only the peptide bond after leucine and before alanine. So peptide bonds, a high-yield science. They're telling us about this hydrolysis event. They say it occurs after leucine, but before phenylalanine. So leucine, phenylalanine, and then some question mark random thing, and that's where it ends up cutting. So that's where this cuts. It's a little messy, but we can follow it right. We're doing a good job. So then they show us this table. Now remember, I don't really love to interpret figures the first time through it, but I am going to read this, and it just tells me that we're looking at the kinetic parameters of these things that we've been discussing with and without compound 1. And I'm just going to take a note of the axes, which essentially are just compound 1 and the kinetic parameters. So if I need that, I'll come back to it, which I probably will. And then they give us a little note that says that this follows Michaelis-Menten kinetics, which is helpful because then we can make assumptions, and the MCAT loves us to make assumptions. It's going to give us a little blurb here saying that the Lineweaver-Burke plot of this inverse V0 versus substrate inverse, which is just a normal Lineweaver-Burke plot, both without compound 1 and with different concentrations of compound 1, generates a set of parallel straight lines with positive slopes. What's that telling me? Follows Michaelis-Menten kinetics. So they're just kind of reiterating themselves. So I think this is probably going to be this looks like a big Michaelis-Menten passage, maybe with some of the basic chemistry sciences in there. So let's go ahead and take a look at this passage, but you'll notice that our flowchart is pretty minimal here, which if you've been hanging around with us for a minute, you know that is not too typical of a, or that's not atypical of a Chem Phys passage. Chem Phys, some of the relationships are there, but you have a lot of basic sciences, and then they like to test you on the specifics of those basic sciences. So you really got to know your crap when it comes to Chem Phys. All right, let's take a look at number 1. Number 1 says, what quantity of compound 1 must be provided to prepare 100 milliliters of solution with a concentration equal to K sub I? Now, glancing at these answer choices, you can see that our quantity is in milligrams. So we know that we've got to eventually get to milligrams. So what do we have? We have milliliters. So we've got milligrams, we've got milliliters, and it says a concentration equal to K sub I. Well, what is that? Does it tell us our concentration for K sub I? And in fact, it does right here. So 60.3 micromolars. So we've got 60.3 micromolars. So this is actually pretty common, or a pretty classic way that the MCAT tests your ability to do some basic stoichiometry. So be on the lookout for this. If they're giving you parameters like milliliters, molarity, and maybe even moles, or like I pointed out earlier, a molar mass, and then they want to ask you answer choices in milligrams, be on the lookout for what I'm about to show you. So here, what we're going to end up doing is we're going to use a manipulation of the classic equation. Molarity is equal to moles per unit volume, and then we're going to take that and multiply the moles times the molar mass, and we're going to end up getting our grams. The MCAT does this all the time. A lot of those hard chemistry questions that you're like, oh my goodness, how the heck do I ever figure this out? If they're like mathy, think about this. This is probably what they're doing. This is one of the best ways that they test your ability to do math quickly. And if you can recognize this pattern, then it gives you a little bit more time to do the math. And I know most of you can do the math if you're given the time. So let's do that. So which of these do we have starting here? Which of these do we have, and which of these are we solving for? So do we have molars? Yeah, we do, right? 60.3. Do we have moles? Well, I don't really see them. Okay, do we have liters, or a unit of volume? Yeah, we do. We have 100 milliliters here. So let's solve for moles then, and that will end up giving us that molarity times liters is equal to moles. So now that we have moles, let's multiply it times our molar mass to get the grams. So do we have molar mass? Where is that? Remember the thing that we highlighted in the first paragraph? It's the molar mass, and it's in grams times moles inverse. If you see something that says a unit to the inverse, and a really easy way to look at that is just to know that that means it goes on the bottom of the fraction. So if you see grams moles inverse, that just means grams per mole. I know that's a simple thing that most of you knew, but if you didn't know that, that would be really helpful. So now we're going to end up saying we've got our moles. So if we can say moles times grams per mole, it'll end up canceling out these moles and leave us with grams. So that's kind of the alphabet soup way of doing it. But now we have to plug in these actual values. So let's take this back to down to what we actually have. So we're going to end up with moles and grams per mole because we have a molar mass, right? Now, what did we say were equal to our moles that we actually had? Molarity and liters, or volume, unit of volume. So what is our molarity? Our molarity is 60.3 micromolars, or I'm just going to go ahead and say times 10 to the negative 6, because that's what micro is. And then for liters, we end up with 100 milliliters, which is just 100 times 10 to the negative 3. So we've got this times grams per mole, and we're actually given the entire value for molar mass, which is 483.5 grams per mole. Get it, don't play that. We're going to say that's 500. Okay, so I round hard on the MCAT. So actually, this is not 60.3 to me. This is just 60 times 100 times, we said, was it 500? That's kind of a fat round, but we're going to go with it. 500 grams per mole. Okay, and that ends up canceling out, right? Because these two are equal to our moles, and this is grams per mole. So our answer choice is going to be in grams. Now we just got to do some basic math. So this is the exponents here. If you're struggling with this, then make sure to check out our math guide or even Maggie's video on how to do some of these more basic logarithm multiplications and things like that. So how do I tackle this? Let's just go one at a time. So let's just go first two times each other. 60 times 100. I just say that's going to end up being 60 plus these zeros. So that's going to be 6,000. And now we've got to multiply these times each other. And that's going to end up being, when we're multiplying negative times a negative, when it comes to exponents, you're adding them, right? Whenever you are multiplying them, you're adding these exponents. So negative 6 plus negative 3 is negative 9 times 500. So 6,000 to the negative 9th times 500. So this is getting kind of overwhelming. So let's just go, let's make sure we can do this as easy as possible. What is 6 times 5? That's going to end up being 30. Okay, now I'm just going to add the zeros. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alrighty. So I've got that times 10 to the negative 9th. So is that in my answer choice? Because this is grams. Well, we have something that's kind of close to it, right? We've got 2.9, which is pretty close to a 3, especially since we know that we rounded up. So our answer choice has to be a little bit lower. Remember, we rounded up right here for the most part. We shaved off 0.3, so that's really not going to impact it. But we rounded up a pretty good bit. We gave ourselves, 15 grams per mole. So our answer, the correct answer is going to be a little bit lower than the number that we're getting. So I want something a little bit lower than something that starts with a 3. So going through these answer choices, 48.4. No, I probably made a huge math mistake if I'm choosing one of those. So A is not the correct answer. B is 24.2. That's within the realm of possibility, so maybe. C is 5.6. That's nowhere close to 3, so I'm going to go ahead and rule that out, say maybe not. And then D is 2.9, and that is really close to 3. So unfortunately, because these are so close to each other, we're going to have to go through and utilize the exponents to see which one we can narrow it down to. You'll notice that the MCAT did us a solid here. They made it to where these answer choices differ by a factor of 10, meaning they're allowing you to round. Okay, this is not 29.2 and 24.2. If that was the case, I couldn't have rounded because I really wouldn't know which one's correct. But it's 2.92. They differ by a factor of 10. So let's see what our exponents tell us the correct answer is. Our answer choices are in milligrams. So to get to milligrams, we're going to remove 6 decimal places. So let's go over 1, 2, 3, 4, 5, 6. And that gives us 3.0 milligrams, which is closest to D. So the correct answer here is D. That's the first question. Okay, pretty involved. So let's look at number 2. It does get a little bit easier. Number 2 says, if only the concentration of the inhibitor is increased, then the enzyme substrate complex or the enzyme inhibitor complex increases. Enzyme substrate inhibitor or enzyme inhibitor increases. So if we increase I, so if that increases, then that leads to an increase in ESI or EI. This is an example of what? What does this look like before you even look at the answer choices? Looks like Le Chatelier's principle, right? So if we're increasing the concentration on one side of the reaction, then we're going to end up leading to an increase or a right shift or a left shift, depending on which side you're increasing. So going through these, A is the Bose-Einstein principle. I'm pretty sure that deals with something like subatomic. I don't know what it is. The fact that I don't know what it is tells me it's probably not the right answer. So maybe not A. B says the Heisenberg uncertainty principle. You are supposed to know this for the MCAT. It's not high yield, but it's the idea that it's very difficult to know a particle's momentum and I think location at the same time. That is not talking about increasing or shifting concentrations. Again, this is subatomic. Both of these are subatomic, whereas here we're talking about things on like a whole molecule basis or a compound basis. C is Le Chatelier's principle. She looking good. So I like answer choice C because it is, again, exactly what we think it's describing, and it's also the only one out of the first three that is talking about things on a compound basis rather than this really microscopic subatomic particle view. And then D says the Pauli exclusion principle. This is also on the MCAT, also expected for you to know, but it's also another thing that's focusing on the subatomic particles. Pauli exclusion principle, mainly focusing on electrons filling valence shells. So I don't like answer choice D either. And that leads to C as the correct answer. Question 3 says, which structural change to compound 1 makes it more water soluble? So I'm just going to rephrase this as which of these is me switching to a more hydrophilic group. So A says replacing benzene, CH with N in the ring. So is CH less polar than N? Yes, right? So maybe to A. B says replacing a carbonyl group with a C double bond CH2 group. Is C double bond O? Is the carbonyl more or less polar than C double bond CH? It's going to be more polar, right? So this would actually make it less water soluble because we'd be removing the polar group. Remember, things that are polar can create a lot of hydrogen bonds. They kind of hog all the electrons, and that's what oxygen's doing here. C says replacing in a bunch of nitrogens, whatever the heck this is, with a bunch of carbons. No, carbons, hydrocarbons, they are not very water soluble. They actually make up a lot of fats and lipids. So I don't like answer choice C because remember we're still removing the potential to create a lot of hydrogen bonds whenever we're removing the ends, and we're adding in these super saturated molecules that are hydrocarbons. So maybe not C. D says replacing NH with NCH3. This one's kind of difficult, but if you are taking NH, it's bound here. I'm assuming it's going to be bound something else. And so these free electrons can create a lot of hydrogen bonds. So that does help with the polarity, juxtaposed to throwing in, making this a methyl group, which kind of clouds this up, makes it a little bit less polar here because the C is not removing any electrons. It's not really changing the electron density too much, and it's also making things a little bit too bulky. So D is the second best answer, but A is going to be the absolute best answer. If we're going to make it more water soluble, or as we rephrased it, make it more hydrophilic, A is going to be the correct answer. And number 4 looks like it's going to be really difficult, but it's not that bad whenever you rephrase it, which is pretty characteristic of the MCAT. It says in these units, what should the approximate values of kcat over km in case of I be respectively when the concentration of I is increased to 180 micromolars? Okay, your brain is probably going crazy and you're thinking of all these equations and you are about to just unlock some new level of profound thinking. Pump the brakes real quick. Remember, we had a huge chart of kinetic parameters. So anytime that they ask you, they're going to say, okay, we're going to change this one value and what's its impact on all these other values. I want you to ask yourself if changing that value actually makes a difference. Okay, so let's go and look. Remember, concentration of I, the inhibitor is what compound 1 is. Okay, so let's go look at this chart. Now, whenever we change compound 1, whenever we change the value of it, does k sub I change at all? Okay, we're adding 60, we're doubling it in the second one. Is k sub I changing at all? No, it's staying 60.3. So you know the correct answer for k sub I is going to be 60.3. There's only one. Okay, it's C. And if you really want to look, if you really want to double check, which I probably would, as a student, then you can go through and you can do this KCAT over KM. But if you'll notice, I think they made a mistake on this graph. I think this graph was supposed to say KCAT over KM here, because this is in millimeters or millimolars and it's 0.15 the whole time, and then it's asking for the question in micromolars, and the correct answer is 150. So I think they made a mistake there. You could do the math if you wanted to, but honestly, if you see that the question's asking about k sub I, you see that k sub I is not changing at all, then just go with the answer choice that has it not changing at all. So that's it. That's the first passage. Hopefully we can only go up from here. There were a couple difficult ones. If you're struggling with some of these sciences, make sure to check out some of our videos. We're walking through a lot of the high yield sciences right now, or you can even check out our guide on those sciences. And the same thing with the math. We have a written math document that's really solid that Maggie and I poured a lot of time and effort into. So check those out if you're struggling with that. Make sure if you want to study with us to go ahead and join the Discord. I'll try to throw the link in the description there too. And I will see you all in the next one.